Hi viewers, my name is Rajkumar from RK Academy. Today we are going to see the topic complex number. It's from higher secondary second year. Already we complete the exercise up to 2.3. Today we are going to see the next topic. So before that 2.4, just we are going to learn something, the properties of the complex numbers. Yes. Before that, what is mean by conjugate? Conjugate of a complex number. So z is equal to x plus iy is a complex number. What is conjugate? Z bar is equal to x minus iy. X minus iy. It's the conjugate of a complex number. Suppose z is equal to 3 plus 2y is a complex number. What about the conjugate? 3 minus 2y. What is the procedure here? We are going to change the imaginary part. So that is called conjugate. Suppose, sir, now I am writing a complex number 4i. How can we write this one? Now you just entered 0 plus 4i. What is conjugate of this one? Conjugate 0 minus 4i. Again, what about this one? Minus 4i. The conjugate of 4i is minus 4i. Okay. Sir, is it 5 is a complex number or not? Yes, it's a complex number. How can we write in the form? 5 plus 0i. What about the conjugate of this one? Now we can write 5 minus 0i. Again, it's 5. The conjugate of 5 is 5. The conjugate of a real number is again a real number. So that is the property. Z is equal to, Z is real. So okay, we are seeing from the property. Now there is a conclusion. What about that? If Z is a complex number, it's the Z bar. Now we are changing the imaginary values. Changing the sign of the imaginary value is called conjugate. Now just we have a property. What about that? Z bar is equal to x plus iy into x minus iy. Okay, what is the form here? Now listen, it's the form x plus iy into x minus iy. So we can write x square minus iy the whole square. Iy the whole square. Yes, x square minus I square y square. X square, we can, what about the minus, I square, it's minus 1. So plus y square. In general, in algebra, x plus y into x minus y is equal to x square minus y square. A plus b into a minus b is a square minus b square. Now from the complex number, a plus ib into a minus ib. What is that? X plus iy into x minus iy. It's the complex number. Conjugate of the complex number, we can write real part of the complex number square plus imaginary part of the complex number square. Suppose there is a problem. Now listen. Okay sir, now I am going to multiply these two. 3 plus 2i into 3 minus 2i. What will happen? Now you write the real part square plus imaginary part square. 3 square plus 2 square. That's all. So 9 plus 4 is 13. So product of the complex conjugate, Z bar, we can write this one as real part square plus imaginary part square. It's a short way to multiply. Okay. Now we are going to see the properties of the complex number. What are all the properties? The very first property, Z1 plus Z2 bar, the whole bar, is equal to Z1 bar plus Z2 bar. You can split and write the conjugates. Okay. Second one, Z1 minus Z2 the whole bar. Z1 bar minus Z2 bar. Third one, product. Z1 into Z2 bar. We can write Z1 bar into Z2 bar. What is meant by this one? Product of complex, these two complex number, and you take the conjugate. It's equal to product of their conjugates. Product of their conjugates. Like that. Fourth. Z1 by Z2. The whole bar is equal to Z1 bar by Z2 bar. In anywhere, Z2 not equal to 0 because its denominator it's not be equal to 0. Fifth one. What is the fifth one? Listen. Z real part of Z is equal to Z plus Z bar by 2. I think it's in the exercise problem. In that exercise we are going to complete, we may complete this one. Real part of Z is equal to Z plus Z bar by 2. Same manner, it's in the exercise problem. Imaginary part of Z is equal to Z minus Z bar divided by 2i. It's in the exercise problem. We will do it. Okay. Seventh one. Z power n the whole bar is equal to Z bar the power n. It's a property. Eighth one. Z is real if and only if. Z is real if and only if Z is equal to Z bar. What is the example? Z is real. Sir, 5 is a real. What is the conjugate of 5? Again, it's a 5. So Z is real like that. So ninth one. Z is purely imaginary. Z is purely imaginary. Z is equal to minus Z bar. Already we seen that. Minus, 4i. So what is the conjugate? It's minus 4i. That's all. Minus 4i. It is Z. It is Z bar. So when we purely imaginary, Z is equal to minus Z bar. We have a proof in the exercise problem. 10th one. Conjugate of conjugate is equal to Z. Now listen, there is a proof. 3 plus 4i. What is the conjugate of this one? 3 minus 4i. Now 3 minus 4i is a complex number. What about the conjugate of that one? Again, it's 3 plus 4i. So it is Z. It is Z bar. Again we are going to take Z bar, the bar, taking again the conjugate. Z bar, the conjugate of Z bar. Okay, it's that. Now we completed the properties. Some of the properties are in, I think, in exercise problem. We will do the problems in that exercise. Okay. Okay. Now the property is over. Just we enter to the exercise 2.5 in the next class. 2.4 I think so. Sorry. 2.4. We can enter the in next class.